Welcome to LeetCode C#. Starting from this video, we're going to summarize the techniques and C# language specifics toward the end of the video. Make sure you watch the video in its entirety to see what would be the main takeaway. In this video, we're going to take a look at the solution to the LeetCode problem 438. Find all anagrams in a string. Let's take a look at the problem statement. Given a string S and a non-empty string P, find all the start indexes of P's anagrams in S. Interesting. It goes on to say, strings consist of lowercase English letters only, and the length of both string S and P will not be larger than 20,100. Let's look at the examples. Example number 1, we have a string S and P, ABC. The output is index 0 and 6, 0 and 6. Example number 2, S is ABAB and P is AB. Apparently, every substring of two letters combination would be the anagram. Let's look at the brute force solution first. To save the time, I'm going to just paste the solution here, and it's looping through the string S for each substring of length M. M is the length of string P. We're going to compare the substring of S and P to see if P is anagram. And this is the function for the comparison. And if they are anagram, we return true. So we add the index of each instances and increment the forward pointer F and get the final result. Let's run it. Works. Let's try to submit. Okay, it says time limit exceeded. So that's why it's called the brute force solution. So we have to improve the performance of the algorithm. Let's look at the big O of the brute force solution. So if we say M is string, the length of string S, and N is the length of string P, and the brute force solution, if you look at the code, for the string S, we're looping through each character. That's big O of M for each substring of length M. We would call this is anagram function, which by sorting it, that's big O of n log n. So n times log n is the function, and for each character in string S, we're calling so many times of the function. So that's the brute force solution's big O. Now apparently it's not fast at all, so we need to improve the algorithm. Can it be big O of M? So the idea is to reduce. So for the anagram, basically it's a rearrangement of letters. So to examine if S is substring of S is a rearrangement of string P, we can count occurrences of each letter in these two strings and compare them. The problem statement says strings consist of only lowercase English letters. That means we only have 26 possibilities of lowercase letter English letter. Since both S and T contain only letter from A through Z, a simple counter table of size 26 is sufficient. So let's see how we're going to do this. Let's say ABC, that's the P, string P. We put the occurrences of each letter in an array containing 26 elements. Each element count the occurrence of each letter. For example, string ABC, for that array, we would have A happen once, B once, C once, the rest of them are zeros. So that's the counter P. A snapshot looks like this, 1, 1, 1, and the rest of them are zeros. Now, the technique we're going to use here is what we call sliding window. Each time we're going to look at the same length of string P, which is 3 letters. That's our window. Slide the window, from the start of the string S toward the end of the S. Each time, by moving one character at a time. When the window moves from the beginning position to the next position here, we also drop the first letter occurrence C in the array and add the new occurrence of the letter to the array. So the array will look like this. So this way we compare these two arrays. If they are identical, then we know that it is the anagram. In this case, for example, here, this one, by moving the window from left to right, we're dropping, each time we're dropping the previous one and adding the new one. At the index 6, we know that each letter occurred once. So this array looks exactly the same as this. So that's another occurrence. That's another anagram. So with this, we're going to come up with our new algorithm. To save time, I'm just going to paste the code here. So for this improved solution, obviously we have a little bit of a safeguard of the function. If the length of S is less than length of P, string P, we're going to return result right away. And we have, this is our counter P, which consists of 26 elements of a constant length array. And this is a counter sliding window, which initialized the same way. And for the string P, we're going to put each occurrence of the letter in P in the counter here. So we're doing, P in the index of I minus the first letter A. So this is 97. Whatever that is, we put in that index, increment the counter. By doing so, we're doing the same for the sliding window S up until to the index of n-1. Afterward, we're going to do our first comparison of counter SW and counter P. If they're the same, we're adding the first occurrence of starting index of P. Here, in this case, is 0. After that, we are going to have the operation of dropping the first letter, or when we slide the window from left to right, we're going to drop the previous occurrence of the letter and adding the new value of the letter. So for example, here we know the array, the counter SW looks like this, which have CBA occurred, each letter occurred once. When we slide the window over, we know we're going to drop the letter C, which is here, original here. So we revert that value back to 0. And we're going to add a new letter E, which is A, B, C, D, E here. Okay, so the array looks like this now. So after that, we're going to compare these two. If the array, when we do the array comparison sequence equal, then we're going to add the starting index of P in the result. Okay, for instance, here, when we get here, each letter B, A, C occurred once, so we have the counter SW, the sliding window, look like this, and it's exactly the same as our counter P. In that case, the P is an anagram. So we're adding the result and returning. So let's run it. Let's submit. Apparently I have submitted before. Okay, so faster than 44.5% of C# submission. So let's look at the big O of the solution. So apparently here, we're going through the length of S. And for the comparison of the counter, this is constant, 26 elements. So that won't contribute to the big O. So we did achieve the big O of M. Okay, let's summarize today's solution. Today we talked about sliding window technique. So I want that to be the main takeaway for today's video. And also pay attention to the C# array comparison sequence equal. I don't know how often you would use this. This is apparently very useful for the algorithm. This concludes the C# solution for LeetCode problem 438. you have seen how to use sliding window technique to solve problems like this one. That's it for this video. Make sure you keep up to date with all of my YouTube content by subscribing and ringing the bell. Thanks for watching.